Okay, good morning class. How are you? Okay, so who still didn't join the class? Can you check the attendance please?
Okay, sure.
Alright. Okay. Okay, so we start our three lessons. Okay, so 3.1, right? So I think you already learned with Mr. Jim, okay, about this chapter or 3.1. Okay, but I just repeat again. Okay. Okay, so you have your notes already, so you can refer your notes, okay, and can complete the notes. Okay, so chapter 3, gravitation. Okay, the first one, how do man-made satellites help to improve human life? Okay, so there's many function of satellites, right? So they can track your locations, like there's GPS, right? Kind of thing. Okay, and also you can get like if you're using Astro, so they are using the satellites too. Okay, and do you ever wonder how does a satellite able to revolve in their orbits? Okay, so how does the satellite, right? They can follow the orbit, right? They can follow the orbit. Okay, so there are various types of man-made satellites revolving in their respective orbits in outer space. Okay, so satellites are invented for communication purpose. Okay, such as weather forecast, say, right? Weather forecast. Okay, and Earth observation. Okay, so why are these satellites are able to revolve in their respective orbit? Okay, so curiosity about the universe has encouraged scientists, okay, to launch spaceship and satellite which can overcome the Earth gravity. So you know that the Earth has a gravity. So how does the rocket, right, or the space ships or satellites, right, they can overcome the Earth's gravity? So because you know the Earth gravity pulls toward the Earth, right? So but how does the spaceship and satellites they can overcome this Earth gravity so they can go to the outer space. Okay, so this is the example, okay, of the using of the satellites. Okay, so at present there are spaceships which are moving far away from Earth. Okay, so such spaceship enable photograph of planets to be taken to benefit scientific invention and also technology. Okay, so this is the example. Okay, so Newton's universal law of gravitation. Okay, so let's see a video first before I continue on this one. Okay, I stop share first.
We saw that the gravitational force is the attractive force between any two objects with non-zero mass separated by a distance. So does the apple fall towards the earth, or does the earth move towards the apple? Or do both move? That the gravitational force is
Okay,
the
wait.
attractive.
Okay, so before we continue on this video, we know that actually the Newton's gravitational law, okay, it comes when the Newtons, right, you sit under the tree, okay, and the apple falls from the tree, okay. So it thinks about the gravity. So that's how does the universal law of gravitation come, okay.
Force between any two objects with non-zero mass separated by a distance. So does the apple fall towards the earth, or does the earth move towards the apple? Or do both move towards each other? It's actually simple logic. This is the earth, and say this minuscule object is an apple. Based on what we learned about the gravitational force, both apply an equal force to attract the other object towards itself. So if the forces are equal, which one will accelerate more? Based on the Newton's second law, we know that the force applied is the product of mass and acceleration.
So F is equals to ma, right? So this is from the Newton's second law. So now we want to know whether is the Earth that moved to the apple or the apple moved to the Earth, okay, when it falls.
So the acceleration will equal force over the mass. The acceleration is inversely proportional to the mass. If the mass is more, the acceleration will be lesser. As the mass of the Earth is much more than the mass of the apple, it is the apple that accelerates towards the Earth and not the other way around.
Okay, so since the mass of the Earth is much bigger, okay, than the apple, so when the mass is bigger, the acceleration will become lesser, right? So it means that the apple has the higher acceleration since it has a smaller mass, but it has a high acceleration. So that's why if that example like the leaf, right? So the leaf it will move toward the earth, not the earth, okay, that move toward the leaf when it falls down.
Hope that makes it clear. Now the question is, how do we quantify this force? To understand this, we need to understand a simple concept. And this simple concept is called the Universal Law of Gravitation. Say there are two objects A and B separated by a distance d. The distance between the centers is considered the distance between the two objects and not this distance. Assume
Okay,
that the mass of object
center to
A
the
is m1
center,
and that of object
okay, of
B
the
is
object.
m2. As object A is bigger, let's assume m1 to be bigger than m2. The universal law of gravitation says that every object in the universe attracts every object with a force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. Let me repeat. The force is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. With this data, we can write it mathematically like this. So if the mass of any of the objects increases, the gravitational force will have more magnitude. And more the distance between the two objects, the lesser will be the
Lower the
gravitational force,
gravitational force.
directly proportional to the product of the masses and inversely proportional to the square of the distance between them. This can be written as F equals G times m1 times m2 over d squared. G here is the constant of proportionality and is called the universal gravitational constant. The equation can be modified and written as G equals F times d squared over m1 times m2. The value of G was found out by Lord Henry Cavendish using a torsion balance.
Okay, so that's about the universal gravitation law. Okay, so I stop first. So we continue to the slide. Okay, so that why do durians fall directly to the ground? That why does the moon revolve around the earth? So haha, my children think like I said Newton too. So this is the story, right? So the scientists of Isaac Newton observed an apple which fell vertically to the ground and the movement of the moon around the earth. So there must be a force, right, that attract the moon so it can be rotate, right? Rotate following the orbit, right? So there must be a force, okay, that attract the moon. Okay, so it will always follow the orbit of the moon. Okay. So this is the first you have to know that you have to explain Newton universal law of gravitation. So this is the formula F is equals to G m1 m2 divided by r squared. Okay, so in 1667, Isaac Newton observed an apple which fell vertically to the ground and the movement of the moon around the earth. So he concluded that a force of attraction not only exists between the earth and the apple, but also between the earth and the moon. Okay, so that's why it can rotate the earth. The moon can rotate the earth. Okay, so activity 3.1 to discuss gravitational force between two bodies in the universe. So a person who jumps out will return to the ground. So what force caused the person to return to the ground? So what force that caused the person to return to the ground? Anyone can answer that? What force that caused the person to return to the ground? Yes, gravitational force. Okay, so gravitational force. Alright, so air molecule remains in the atmosphere without escaping to the outer space. What force act between the molecules in the atmosphere and the earth? So you know that around us there is an air, right? So how does the air is still intact in the atmosphere? It's not going outside from the atmosphere. So there must be a force that attract the molecule of air so it can stay inside the atmosphere. So it still recalls as a gravitational force. Okay. Alright, so to discuss the gravitation, and then the next one, the moon revolve around the earth without drifting away from its orbit. Okay, so the earth exerts a pulling force on the moon. So does the moon also exert a force on the earth? So the answer should be yes. Okay, yes. Okay, a leaf falls from a tree. Both the leaf and the earth experience the same gravitational force? Yes. Okay, it experiences the same gravitational force. Okay, from the leaf and also from the earth to the leaf and also from the leaf to the earth. So it still experience the same gravitational force. Okay, so what is the effect of those forces to the movement of the fallen leaf and the earth? So the leaf and the earth move towards one another. Okay, so this is that. Why does the fallen leaf move towards to the ground? So this one we already explained because of the mass, right? Because of the mass of the earth is much bigger. So A is actually F over M, right? So when the mass of earth is bigger, the acceleration is smaller. But for the leaf, right? So the mass is lower, the acceleration is higher. So that's why we see that the leaf, right, it moves towards the ground. This is because of the acceleration. Okay, the difference of the acceleration between both two. Okay, gravitational force. So gravitational force is known as a universal force because it acts between any two objects in the universe. It's not only like, let's say, from the moon to the earth. Okay, it's same also like the sun to the earth or the sun to any other planet. So it still have the gravitational force between them. So if they don't have the gravitational force between them, then they cannot rotate, okay, according to their own orbit. Okay, so actually it's not for the moon and the earth only. It applies to the all system, our solar system. It means from another planet to another planet also, they must have the gravitational force. Okay, so they're not like crashing, okay, into one another. Okay, so gravitational force is known as universal force because it acts between any two objects in the universe. So gravitational force exists between two bodies. So even like let's say you are at the school now, okay, and then you sit beside your friends. So there is a gravitational force also acting on both of you. Okay, but because of your mass is smaller, okay, so that's why we cannot feel the gravitational force. Okay. So both body experience a gravitational force of the same magnitude. Okay, so let's say this is Earth. So let's say this is 50 Newton. Let's say. So this one also must be 50 Newton. So the both of the gravitational force is same between two objects. Okay, so let's say this is the sun. So gravitational force between the sun and the earth. Okay, so let's say this is 100 Newton. Okay, so this is also equal 100 Newton also. So the earth and to the moon, let's say this is 100 Newton. So this is also 100 Newton. Okay, so this is the gravitational force that acting on the planet. Okay, and also the sun and also the moon. Okay, so in the year 1687, okay, so Isaac Newton presented two relationships that involve gravitational force between two bodies. Okay, so this is body one is M1, mass of the object for body one, and this is the mass for the body two. Okay, Right, so this is the distance r. So we must take note that it's from the center, okay, from the center of the body. So from the center and to the another center for another object, this is r. Okay. Alright, so the gravitational force is directly proportional, okay, to the production of the masses of two bodies. That is, F is directly proportional to M1 and 2. So M1 multiplied by M2. Okay, so that is the first relationship that Isaac Newton discovered. Okay, and then okay, so it's not that the gravitational force is inversely proportional to the square of the distance between the center of the two bodies. That is, okay, so that one, the first one is F is directly proportional to M1 plus M2, right? So you have to multiply the mass of the object 1 and also the mass of object 2. So the second relationship that Isaac Newton discovered, that is that gravitational force is inversely proportional to the square of the distance between the center of the two bodies. So this is the second relationship that Isaac Newton discovered. Okay, so then they combine these two relationships. Okay, combine these two relationships. So it will form that F is directly proportional to M1 and M2, but inversely proportional to R squared. So this is actually the formula for the Newton's Universal Law of Gravitation. So this is F is equals to, then you have to replace, right? If you want to change the directly proportional, the symbol here, you have to put a constant to it. So it become F is equals to G M1 times M2 divided by R squared. Okay, so the G is actually the constant value. It's same like the G for the, if you want to calculate the weight, right? Weight is W is equals to mg. So G is actually the constant here, right? So means the value is not changing. It's always same. So this one is also a constant value. Okay. So F is the gravitational force between two bodies. M1 is the mass of first body. Okay, M2 is the mass of second body. Okay, R is the distance between the center, okay, of the first body and the center of the second body. And G is the gravitational constant, that is 6.67 times 10 power of negative 11. Okay, and M squared kg negative 2. Okay, so for this one, the constant you don't need to remember. Okay, they will give you in the exam. Okay, so this is the example one. Okay, so the first one you have to list out what is the information given. Okay, so this one is actually between the mass of the durian and also the mass of the earth. So the mass one is durian and the second one is the earth. Okay, M2 is 5.97 times 10 power of 24. And the distance between the center of the durian, okay, let's say this is the earth and this is the durian. Okay, so from here to here, okay, so this is the R. Okay, must be from the center of the earth to the center of the durian. So that is 6.37 times 10 power of 6. Okay, so already given that, then you just substitute in the formula, you can get the value of the force of the gravitational force between these two objects, means from the earth to and the durian. Okay. Okay. Before that, okay, so let's see for the question number 2. Okay, for question number 2, so a rocket at launching pad experienced a gravitational force of 4.98 10 power 5 Newton, 10 power of 5 Newton. So what is the mass of the rocket? So this one is giving you the force already, okay, and you need to find another mass of the object. So this one is actually the mass of the rocket, and the mass of the earth already given, and you can see here the mass of the earth is also the constant value. Okay, and the R also already given, and also the G. Okay, so you just need to substitute, okay, and find the value of M2. Okay. Okay, so let's see for the Next question. So solving problems involving Newton's Universal Law of Gravitation. So gravitational force acts between any two bodies, including those on Earth, planet, the Moon, and also the Sun. So what are the effect of the mass and distance between two bodies on gravitational force? Okay. So imagine you and your friends are bodies on Earth. So this is your mass M155 and your friend is M2 is 65 kg. Okay. So this is you and your friend. So calculate the gravitational force F is the distance between both of you. R is 2 meter. So I want you to try to calculate first and give me the answer. Okay, by using the formula. Okay, F is equals to G M1 M2 plus R squared. So please calculate now. Any question you want to ask?
Yeah,
Yes.
I think you're going a bit too fast. Can you like slow down the pace?
Oh, right. Okay, okay. So, so far, can you understand me to repeat to any part of it?
The first part I'm okay, but that really depends on the rest.
Okay.
Thank you.
All right. Yes, 6.67 times 10 power of negative 11. I think. Wait, let me check first. Yeah, negative 11. 6.67 times 10 power of negative 11. 5.96 times 10 power of negative 8. Any other answer? Any part that you need me to repeat before this? Because I thought you already learned with Mr. Jim, so I thought you already understand. So I just spoke very fast, it's just like recall. But it's okay if you want me to slow down, you just tell me, okay? 5.96 times 10 power of negative 8. Yeah, you're correct. Okay. So the answer is 5.96 times 10 power of negative 8 Newton. So you can see the force is very small, right? So that's why you cannot feel the gravitational force, okay, if when you sit beside your friends, because of the force is very small, because this is actually because of the mass, okay? Because of the mass, if you want to feel the force to be you want to feel the force, it must be the mass must be bigger, like the earth, right? The earth, you know that the mass is very big, so that's why you can feel the gravitational force. But if you only like between you and your friends or any object, okay, that's surrounding you, like let's say your laptop or anything, so that one is very small, so that's why you cannot feel it. Okay, so let's increase the value of the distance from 2 to 4. Okay, so now, okay, you're using the same mass before, okay, but now you have to change the R there from 2 to 4. Okay, so let's try to change and find the gravitational force. Then we can compare. How about the value? Is it increasing or is it decreasing? Okay, because now we increase the radius, right? So how about the force? Whether the force 1.49 times 10 power of negative 8. Okay, so any other answer? Maybe you got another answer. Same. So you can see here, right? The gravitational force is decreasing, okay, as the radius is increasing, and we already know that Newton's discovered the two relationship, right? The first one is F is inversely proportional to M1 and M2, and another one F is inversely proportional with the radius. Okay, so now before this we're using 2 and then we change to 4. So means the radius is increasing, okay, but the force is decreasing, right? So it's true. Okay, so let's check whether it's correct or not. Okay, so 1.49 times 10 power of negative 8. Okay, so when the distance between two objects, okay, two bodies between them is increasing, the gravitational force is decreased. So correct. Okay, so hence more separation distance will result in weaker gravitational force. Okay, so means if the two objects move further, okay, so the gravitational force will be decreasing. Okay. Alright, then we change the partners. Okay, we change the partners. Okay, now you have to calculate the force, okay, for this one. This one you just use the same radius, but we change the mass. Okay, we change the mass. Before this is 55 and another person is 50, right? So now we change the to 55 and 75. Okay, so let's find the gravitational force between them. Weekend who's not here? Because should be 16, right? I think now it's only 15. Oh, sure. What's wrong with him? I asked in the parents group. Did he join the class before this? Before this, do you get? Before this, yeah, she's in this in the class. What class before this? Oh, physics is today first class. Or before this, you don't have online class for another subject. Okay, never mind, I will text his father. Okay, do you got the answer for this one? 6.88 times 10 power of negative 8. Okay, 6.88, 6.878. Okay, so you can give it the 2 or 3 decimal point. Okay, so if you compare, the value, right? The value, okay, the one that we used before 55 and 50 kg, right? So you can see the gravitational force is increasing. So that's proof the first relationship of the Newtons that said that force is directly proportional to the multiplication of the mass of object 1 and the multiplication of object 2. Okay. Right. Farah, you've got 7.88. Let's see. Or is it you type it wrongly? It should be 6.88. How can you get 7? Should be 6.88 times 10 power of negative 8. Okay, so it proved that the first relationship. So before this, we proved the second relationship, that F is inversely proportional to 1 over R1 and R2. Okay, and the second one, just now we proved that F is directly proportional to the N1 and N2. Okay, so we already proved this one. Okay, just now we proved this one, right? Okay, we increase the radius between the 2%. Okay, so when the masses is increases, the gravitational force between them will also be increased. Okay, what is the effect of the distance between two bodies on gravitational force between them? Okay, so this one we already calculate. So when the distance between two bodies between them is increased, okay, so hence more separation distance will result in weaker gravitational force. Okay, so it means the radius bigger, the gravitational force is lower. Okay, why is the magnitude of the gravitational force between you and your friend is small? So anyone can answer that? Why is the magnitude? Because this now I already explained why. So can you answer that? Why is the magnitude of the gravitational force between you and your friend is small? Yeah, because the mass is small. Okay, because the mass is small. Okay, if you compare to the Earth, okay, and the Moon, okay, of course we are much smaller. Okay, so the masses between two bodies of small mass has a very small magnitude. Okay, so the larger the mass of the body, the larger the gravitational force. We already proved that one. Okay, and the larger distance between the bodies, the smaller the gravitational force. So this one also we already proved with that by we increase the R, right? So R2, then another one is R4, right? R is equals to 2, then we change to R equals to 4. Then you're using the Newton's gravitational formula, you can see the value of the force is decreasing. So the next one, okay, to solve the problem involving Newton's universal law of gravitation for object on the Earth's surface. Okay, so just now we just use the our body, like the one or the object is on the surface, the Earth's surface. Now we try to find the Earth and the satellite, and also the Earth and the Sun. Okay. So what is the gravitational force on the man-made satellite before it launched? So before it launched, okay, so the man-made satellite mass is 1.20 times 10 power of 3, and the distance between the Earth and the satellite is 4.22 times 10 power of 7. Okay, so this is the formula. Okay, so this is the Earth. Okay, this is the Earth. Okay, the mass and also the radius. Okay. Okay, so this one you have to use the formula 6.67. Okay, by using this formula. Okay, so this is the gravitational constant. So this is 6.67 times 10 power of negative 11. So change to negative 11. Okay, this one, the power of negative 11. Okay, and then this is the mass of the Earth, and this is the mass of the man-made satellite. Okay, and this is the radius. Okay, this is the radius. Okay, so this is before it launched. Okay, so this is before it launched. Okay, that means it's still on the Earth. Okay, so this is the force. Okay, so it's still like it's still at the Earth like that. Okay, this is, let's say this is the satellite. So it's still on the Earth, on the Earth's surface. Okay, before it launched. So this is the force. Okay, So when we already launched the satellite, okay, so this is the amount of this is the value of the force, okay, and after we launch it, okay, so of course now the distance will be different, right? Oh, sorry, okay. So after it's launched, okay, of course now the R is now is different because it now moved further from the Earth. So now the R will increase, okay. Okay, so the mass of the sun is bigger than the mass of the earth, and we already know that, and also is bigger than the moon, and also a moon is bigger than the satellite. Okay, so compare between the earth satellite distance and the sun earth distance. So can you try to compare the earth satellite and also the sun earth distance? Which one is bigger? This is the earth satellite and the sun and to the earth. Which one is bigger? Yeah, sun and earth much bigger. Okay, so distance. Okay, so predict the difference in the magnitude of the gravitational force between main mass satellite and the gravitational force between the sun and the earth. Okay. So can you try to predict the difference? Which one is bigger? The magnitude of the gravitational between main satellite or the gravitational force between sun and the earth? Which one is bigger? By using this relationship, sun and earth. First, because of the uh, sun and earth and the sun, earth and man-made satellite. Are you sure? Mass of difference is high. Then how about the radius? The radius of the sun to the earth is much bigger, right? You're right. So the gravitational force between sun and the earth is much bigger because of the mass. Okay, because of the mass. Of course, the mass of the sun and the mass of the earth is higher. Okay, so that causes the gravitational force between the sun and the earth is bigger. Okay, now you have to calculate the gravitational force between Earth and satellite and Earth and Sun. Okay, so we already know before this, if the satellite is still not launching, it's still on the Earth. So you already calculate the force. Now when it launching, the R will become bigger, right? So you have to plus with the distance, right? The distance of the satellite here. Okay. Can you try to calculate this one first? And then I will teach you how. Already give you all the value here, okay, from the earth and the satellite, okay, and then the earth and the sun, okay. But you have to be careful because the R here, this is the radius of the earth is here, right? This is the R, okay. But let's say now when it already launched, so of course they still have a difference, the distance between the earth and the satellite, right? So this should be, let's say, fish, right? So means you have to be careful with the value, this value here, okay? Because the R is actually the radius of the earth if the object is on the earth. Okay, now when the satellite is launching, so means there will be increasing of the distance. Okay, you try to calculate it first, then I will teach you. And the main map satellite, it says the distance between the Earth and the satellite is 4.22 times 10 power of 7. So means it's already give you the value of H. Okay. Also try. 1.13 times 10 power of negative 10. We can. What is your R? What is your R? What R that you use? Did you add the radius of the Earth? Okay. Okay, any other answer? 9.84 times 10 power of 21. Okay, any other answer? Others? Sajid, you have another answer? .838 times 10 power of 11. Okay. Sajid, this is from Earth to satellite. No, teacher, you don't get the you don't get the answer yet, or you don't know how to do. I got my error for a few times. Okay. Wait for a moment. 9.838 times 10 power of 11. So your answer is same like 30. Yeah, I find my. Okay. So let's see. Okay, which one your answer is correct? So this is all the value given. Okay. So this is a very given. So first, the gravitational force between the Earth and the satellite. So you should get 202.202.46. Sorry, 0.56. Okay. So maybe you forgot to square the R there. Okay. So let's try to calculate by using the calculator. Okay. So the first one is 6.67. Okay. 6.67 exponent -11. Okay, and times by the mass of the Earth is 5.97, right? It's 5.97, right? Exponent 24. Okay, and against have to time the mass of the satellite, that is 1.2 exponent 3. Okay, then you have to divide. Okay, so just now, right? Just now, the if you want to calculate the gravitational between Earth and the satellite, you have to consider from the radius, from the center of the Earth. Okay, even let's say this is the Earth, and let's say this is the satellite. Okay, so you have to, the R is actually from here to here. Okay, from the radius of the Earth to the satellite. Okay, so this is R, right? The radius of the Earth, and this is H. Okay, so if you want to find the R's, this is the formula, right? M1, M2, then divide by R square, right? So the R square is actually the R plus H, then you square it. Okay, so you didn't you have to take from the center of the Earth, not like from the surface of the Earth. Okay, the distance between the surface of the Earth to the satellite. No, you have to take from the radius of the Earth. So you have to calculate from the radius here. So R plus H square. Okay, is it okay? We can. Okay, so we continue. Okay, to calculate. Okay, and then 1.2 times 10 power 3. Okay, so you got the answer. Okay, and then you have to divide, right? You have to divide. Okay, and then you put the symbol of, you put a bracket here. So this one, the bracket means the calculator know that it has to calculate inside of the bracket first. Okay, so the R, the radius of the Earth is 6.37 times power, 10 power of 6. So exponent 6, okay, plus, okay, then the distance of the Earth to the satellite, the H there. Okay, so 4.22 exponent 7, okay, then you close the bracket, then you put the square symbol here. Yeah. Wait, I check first whether, okay, so try the answer. So you got the answer 2.202.56. Okay, so are you clear? So teacher, can you use the exponent? Yes, yes. I know it's hard to type, right? 10, and then you have to put the power symbol there. Then yeah, use the exponent. I'm using that one. Before this, you use that one. 10 power of -11 like that. Yeah, just use that one. It's much easier, right? Just put the exponent, then type the power of the. You can get the same answer, and we already prove it. Yeah, yeah, can get the correct one. 202. So for those who got 9.838, okay, I think you forgot to square root the radius there, right? So that's why you got 9 point, yeah. So you better be careful, because mine also like that. Okay, and remember the R there, okay, R there is, let's say, the one that we used before, right? The F is equals to G, F is equals to G M1 M2 R square. Is mean is only when the object is on the surface of the earth. Okay, on the surface of the earth. Okay, so when the object is already, let's say this one, the satellite is already launched. No, it means the object, the satellite is not, it's not anymore on the earth, so it's already on the space. Okay, so in the outer space, so you need to consider the distance also. So this one, when the object is already, is not on the surface on the earth. Okay, not on the surface of the earth. Okay, we have to consider the radius of the earth also. Okay, anything you want to ask, teacher? Yeah. That's it's okay. Then we calculate the next one, the earth and the sun, I think, right? Yeah. So wait. I change to another one. Okay, this one. Now we have to change to calculate the gravitational force between earth and sun. Okay, so try to calculate the earth and the sun. Okay, before this earth and the satellite, now earth and the sun. On Monday, how many of you will come? Because I want to give the module, right? We say for those who cannot come, right? I will just put at the guide there. Then, as usual, you have to go and yeah. I think I will come on Monday, unless I have still got the paper to mark. That's a different story, lah. So this one, do you need to like R plus H or something? Do you need to put like R plus H? Or we just use the distance between the earth and the sun, 1.5 times the power. Try to think. The earth and the sun is 1.5 times 10 power of 11. Is it already have the radius of the earth? 1.3 times 10 power of 15. Did you already square it? We can 1.3. All same, huh? Right. So let's see whether it's correct or not. Okay. Wait. Why it go back to the first slide? Here, right? Why you got 3.36 times 10 power of 2? 1.29. Did you take the see which one that you wrong? Did you take the R is you add the radius of the earth also? The distance. Then the distance you take 1.5, right? Then this is correct. You use this one to calculate, is it? Okay, so let's see why is the wrong. Okay, 6.67 exponent negative. Yes, that's me. Wait. The math, yeah. I noticed now. 7.35, right? Okay, never mind. We calculate first. And then the L is 5.97. 5.97 exponent 24. Okay, so you got this one. Okay, and then you divide. Okay, bracket. We take the radius of the sun is 1.5 exponent 11. Then we square it. Yes, you got 1.300. Yes, 1.3 times 10 power of 15. Correct. So this one, the value of the sun is wrong. We exchange it first. $7.3. So we got 1.30. Weekend dah betul. Kan gigi weekend kira. Okay. So now you already understand how to use the formula and how to differentiate when you have to add the R plus H and when you have to only use the R. Okay, they say that one for the satellite. Okay, for the R there is they say the object is still on the surface of the earth. We use R. So they say the object now is already go to the outer space. So now we have to use R is R plus H. Okay, but that one is from earth and from the sun. That one is already given the R. So you don't need to plus H anymore. Okay. Okay, so for this one, actually should be okay. So the gravitational force between the earth and the moon is 2 times 10 power of 20 Newton. What is the distance between the center of the earth and the center of the moon? Okay. Okay, so let's say this one I want to, okay, try to calculate. Now I already give you the force, okay, and you have to find the center, the R here, the value of R, okay, the center of the earth and the center of the moon, okay. So I give you the info first, okay, like from this one I think they give you all this. Wait, yeah. The force is 22 times 10 power of 20. You already have the handout, right? So you can refer on the handout, I think. So I don't need to show you. Because I know you must ask me with what is the mass of the earth, mass of the moon, right? Now the F is given, the M1, M2 also given, G, you have to remember that one. Okay, and then you need to find the R. Okay, but you have to remember that one is R squared. So when you got the answer, you got the R answer, you have to square root first. Teacher, can please show the mass part because in the handout it's not here. Okay, wait. Is it okay now? Okay. So far, are you okay? Can you understand for this part? How to use the formula? What is the relationship? Jawapan panjang. Yeah. No decimal point. You change to the no. It's got. I ask you. No decimal point. I'm asking. 10 of power of 28. We can. Your answer also 10 of power of 28. But I can see there's a decimal point there, so it cannot be like 10 power of 28. If yours is like 1, 2, 3, 4, 5, 6, 7, 8. 10 power of 8, right? If we can also change to the standard form. No, mine's just like that. So ketiga got 10 power of 28. Any other one? Sajid, why you're so quiet? Usually you're quite active giving answer to me. Are you still having problem with your calculator? Yeah, I can get. Your calculator is same like mine, right? Or you using another type of calculator? Just now you can get the answer like mine. Same as we can answer. No, I can. Are you sure what type of calculator that you use? You're using a Casio or there's two types. The one that mine is FX 570. Yours is what? I got it. You say mass zero. Why you always get mass zero? You're using a different type maybe. What type of calculator do you use? Eugene 3.83 times 10 power of 8. Okay, so let's see which one is correct. 57 ms. Same like mine. And same like the one that I'm showing you. Oops. Oh, I forgot. 3.82 times 10 power of 8. Okay, so it's correct. Teacher, chemical answer and ketiga answer is same, right? Ketiga got 10 power of 28, right? It's actually 10 power of 8 only. It changed it to standard form, then can get the same answer. We can got is it which one? 3.83. Wait, I see the 3.825. Since if the critical is 10 power of 28, if 10 power of 28 is like, because we can now, if you change the standard form, 1, 2, 3, 4, 5, 6, 7, 8, right? But this one, yeah, the answer is correct, but I think the power is wrong, right? Ketiga. Oh, ketiga, did you type it wrongly? Oh, Eugene. Oh, I thought tukar to standard form only. Yeah. Remember, if you got the like long answer like this, you change to standard form. Okay? It's better. And even in the answer in the schema also, they give you in the standard form. Okay? So no one got correct. I think who got 3.83883 or 825. It should be 3.8383 because 5 you have to round off to 3, right? So it should be 3.83. So Farah is correct. Eugene also correct. Very good. Okay. Yeah. So it should be 3.83 times 10 power of 8. We can, but if you give the answer like that, it's still considered correct, but it's like maybe like the second answer. Yeah, the first one is like that. Okay. So good. Sajif, let's help Sajif to use his calculator. Sajif, first what you have to do, you have to multiply this one first, right? So 6.67 exponent negative 11 times 5.97 exponent 24. And Sajif, number one I key in is right. Means for this one you key in this one is right. And then the numbers I key in is right. Okay. Then maybe you square root it wrongly. It come out as the arrow. Never mind, I calculate for you. Oh my step, just the answer can get. Okay. Okay, you got like this, right? Okay, and then we know that this one, move this side, then you have to divide by 2 exponent 20, right? Okay, and then you got this one, then you have to square root the answer, right? See? Did you square root the answer? You cannot get like this. Okay, never mind. If you have time, can you record like what you do, okay, on your calculator? Then you can send it to me. Then I can see what's wrong, or maybe and you have to check your calculator, right? Make sure it's like only D here. Sometimes they have like, if you put the other function, your answer sometimes can be wrong too. So make sure you have only D here. You have to reset your calculator. Okay. Okay, so next time we continue for the next lessons. Okay, so anything you want to ask, are you clear now? And make sure for those who still didn't answer the questions, the quiz on the Google Classroom, please do. Okay, if you have any question, did you get it right for the relationship, the one that asks you what will happen if we double the radius? See, so the calculator was on different mode. See, that's why you have to check. Okay, then try to calculate again. So tell me, still you can get the correct one. Okay, try to check. Okay, so if you have any answer regarding to the quiz, you can text me. Okay, so if you have nothing to ask, okay, I hope you are clear for this part. So the next part, on next Thursday, I will continue on the next part. And can you please like helping me, like let's say if the teacher don't want to do the Google Meet with you, and also like give you more time for you to do the homework, means that you can submit other time. Okay, can you tell me so I can do the online class with you? The Google Classroom, yes, because it's already expired. Because I setting like only certain part only. Can you please tell me so we can move faster? Okay. Yeah. Because I set the due is on 12:30 tomorrow. Yeah, yesterday. Okay. So never mind, I will give you another link. Okay. For those who still didn't answer. Okay, so please tell me if the teacher didn't want to do the Google Meet and they give you a long time for you to answer the question, and you can manage to answer that one. Can you please tell me, then I will do the online class so it will cover what I already missed with you. And the experiment, I'm sorry to say, for right now the pengetua didn't allow us to do the experiment. We cannot go to the lab also. So the experiment have to be postponed, okay, until the pengetua said we can go to the lab, because now every day our school has cases, right? So you want to limit your movement in class. Okay, I'm sorry. Okay, so see you next Thursday. Okay, so take care, right? And thank you, class. Okay, bye.
Thank you, Chef.
Thank you, bye.
Thank you, teacher. Bye, teacher.
Bye, teacher. Bye.
Thank you, teacher.
Bye, welcome. Yes, it will be on YouTube. I will put it on YouTube.